In this video, we will be doing Chapter 3, Organization of Data for Class 11 NCERT. The exercises of the questions solved from question number 6 to question number 11. Now here in this question number 6, we have in a city of 45 families were surveyed for the number of cell phone they used. Prepare a frequency array based on their replies as recorded below. So how will we write the answer? First, we will write down what is frequency array. Frequency array represents the frequency distributions of the discrete variable. So what is a discrete variable? We know that the variables, the values that are having the certain values, they are known as the discrete variables. Now for this, the table is given here. So here we have the 45 families using cell phone, number of times they are using cell phone. The table is given in 3.58. Now we will have to find out the frequency distribution or the frequency array. So what we do, we first write in the column, first column will have number of cell phones used by families, and then the second column it will have number of households. So number of cell phone used by family, so number of household one. So when like for zero cell phone, that no one uses cell phone, number of household is what is, it is only one. Next one is what? One. Number of cell phone used by families, one is 7. So 7 number of households they use one cell phone. Next one is what? 15. Now 15 number of households they use two cell phone. Then we have 12. So 12 number of households they use 3 cell phones. Then we have 5 number of households they use 4 cell phones in their families. Then we have 2 number of families or number of households we use which uses 5 number of cell phones by their families, and again 2 number of households they use 6 number of cell phone by their families, and the last one is what? 1 number of household which uses 7 number of cell phones by their families. So in this way we calculate the frequency array for the discrete variable, which is number of cell phone used by families, and number of household is the frequency. Now we come to the next question, which is what is loss of information in classified data. So loss of information, from where does it comes in the classified data? So we find that loss of information comes when we summarize the data as per the class mark or the class midpoint. We don't take the original observations together. We only take the midpoint. So in this way there is loss of information. So loss of, and what is a class mark or midpoint? We have done this before. It is the average of the upper class and the lower class limit. So loss of information in the classified data in statistical method is the summarizing of the value of the class mark or the midpoint and not the values of the observations in that class. The loss of information in the classification of data as the distribution of frequency is the inherent shortcoming. The loss of information in classified data makes the raw data more concise, reduces detail when the raw data is grouped in frequencies, classes, or categories. So it is grouped in frequencies, classes, or categories for classification, and we take the class mark or the midpoint. So here there is loss of information. Now question number 8 says, do you agree that classified data is better than raw data? Why? So here we will have to compare classified data and raw data. So first, raw data, what is it? We know that raw data, they are what? They are unorganized data, they are messy, they are unprocessed information collected from the source, direct source. But raw data is original. But what we know that raw data is original and it has the maximum detail. So it have all the maximum details in it. And so there is what? There is no loss or zero loss of information. Now when we come to the classified data, they are grouped data. But what? They are organized, they can be easily manageable, they are arranged, and so they can be grouped into classes or frequencies. They can easily be compared and be selected. Clarity and quick insights for any decision making processes is very much possible from classified data rather than raw data. So for flexibility, detailed analysis, and originality of the data, we require raw data, where raw data is better. But when there is requirement of clarity, summarizing, pattern and trend revealing, for the quicker decisions or comparison in statistical analysis, then we consider classified data is the best one. We come to question number 9, which is distinguish between univariate and bivariate frequency distribution. So for this, we will have to differentiate between univariate frequency distribution and bivariate frequency distribution. From the name, we can understand that uni means one and bi means two. So here the first one will be what? The first difference, that univariate deals with one variable while bivariate deals with two variables. The next difference will be what? The univariate frequency distribution shows how frequently the value or the class of the one variable takes place. And here bivariate says it shows how often the values or the classes of the two variables occurs. The next difference is what? Univariate frequency distribution, it focuses on that one variable characteristics. Here the difference for the bivariate, what it will be, it focuses on the characteristics of the two variables. Next difference will be what? Univariate frequency distribution is presented in a one-way table, while bivariate frequency distribution is presented in the two-way or contingency table. Example of univariate frequency distribution is number of families residing in a complex A with their income as their frequencies. Now, example for bivariate frequency distribution will be what? Sales in rows and marketing in columns for company A in the year financial year 2025. So this is an example of bivariate frequency distribution. Now we come to question number 10, which is prepare a frequency distribution by inclusive method taking class interval of 7 from the following data. So first we will understand what is an inclusive method. Inclusive method are those methods where the upper class limit and the lower class limit of the first and the second class, they are not equal. So here what happens, the given values are given in table 3.11, and from here we will have to understand, or we will have to frame the class interval taking 7. Okay, like 0 to 7, the class interval will be 0 to 7, then 8 to 15, 16 to 23, 24 to 31, and 32 to 39. So we will have all these values presented accordingly. So from 0 to 7, it is given by a black tick, and we find that there are 15 number it has been presented. So you find the black tick here, all the black ticks, there are 15 in number. So the number of observations for the class 0 to 7 is 15. So black tick is 15 in number, and so the frequency is 15. That means the classes from in interval from 0 to 7 is 15. Next one is what? 8 to 15. 8 to 15, how many like numbers are there? It is 16. So all the red colored tick, there are 16 in number, and all the red colored tick numbers, see, they are all from between 8 to 15, and so there are 16 numbers. So here the frequency will be 16. Accordingly, we will have for 16 to 23 all the blue colored mark, which is 13 in number, and the frequency is 13. Then we have from 24 to 31 all the orange colored mark, which is 11. And the last one is what? 32 to 39, which is the light green color mark, which is 5. So the total frequencies of all these numbers is what? 60. Now here in question number 11, which is the last question, the quick brown fox jumps over the lazy dog. Examine the above sentence carefully and note the numbers of letters in each word, treating the number of letters as a variable. Prepare a frequency array for this data. So for this answer, what we will have to do, we will write the sentence once again. The quick brown fox jumps over the lazy dog. And now what we will count the letters in each of the word in the sentence. So the first word is what? The. So here we have 3 letters. For quick word we have 5. Then for brown again we have 5. For fox word we have 3 letters. Jumps we have 5 letters. Over we have 4 letters. The again 3 letters. Lazy 4 letter. Dog again 3 letter. Now the next step will be listing all the letters. So the number of letters are the variables. We consider this variable as y. So in this variable we have the values here 3, 5, 5, 3, 5, 4, 3, 4, 3. So we got this, the number of letters in each word. So from this we will calculate the frequency array, or we will just draw the table of the frequency array. So for the number of letters variable, which is y, for number of letter 3, okay, so how many frequency, how many times it is there? So number letter, that means 3 comes how many times? We find that here 3 comes 4 times, so the frequency will be 4. 5 comes how many times? 5 comes 3 times, so the frequency will be 3. Then we have 4 comes how many times? 4 comes 2 times, so the frequency will be 2. So we know that frequency is the number of observations. So the number of letters coming how many times is the frequency. So in this way we will understand how to frame the frequency array, and we did it, and the total frequency is what? 4 plus 3 plus 2, which is 9.